Hello everyone. Find all distinct finite solutions of limit of this expression when x goes to minus infinity. This is not a hard question, but it needs a little bit of work. So on the numerator, we have x to the power of m plus 3 times x to 4 plus 3. And on the bottom, we have x to the power of n plus 2 times x to the power of m. And m and n are positive integers. So let's assume that m is, since we have a power of 4, let's assume that m is more than 4 and n is less than 4. Then if we call this limit as L, then L becomes limit of, when x goes to minus infinity, of on the top. So when x goes to minus infinity, only the highest degree will matter, basically. So on the top we will have x to the power of m, and on the bottom, since n is less than m and m is 4, then we will have 2 times x to the power of m. This is gonna be x to the power of m's will cancel out. This is gonna be 1/2. Then let's consider where m is equal to n and both are more than 4. Then on the top, so the limit of x when it goes to minus infinity, then on the top we will have x to the power of m. Since m and n are both more than 4, so we will have only x to the power of m. And since they are equal, we will have 3 x to the power of m, which this is 1/3 when x goes to infinity. Then if both m and n are equal and equal to 4, so if m is equal to n and equal to 4, these two terms will sum up. It's going to be 3x to the power of m, and on the top we will have 3x to the power of 4 plus 1x to the power of m. So our limit will be limit of when x goes to minus infinity. On the top we will have x to the power of m plus 3 to the x power of 4, and x and m is 4, so we will have 4x to the power of 4. And on the bottom we have 3x to the power of 4, which is going to be 4/3. Another case will be when m is 4 and then n is less than 4, right? So then L will be, so when m is 4, we will have 4 or 1x to the power of 4 plus 3x to the power of 4, which is going to be 4x to the power of 4 when x goes to minus infinity. And on the bottom one, n is less than 4, so this doesn't matter, and we will have 2 times x to the power of m. So it's going to be limit of x goes to minus infinity of, on the top we will have 4 times x to the power of 4, and on the bottom only 2 x to the power of m, which is 4 is important. So this is going to be 2. So another case will be n more than m and both more than 4, right? If this case happens and n is more than m and more than 4, then the limit will become limit of x when it goes to minus infinity. Top, m is important, x to the power of m is important because it's more than 4, and this vanishes, this grows rapidly, and more than that. So we will have x to the power of m on the numerator, and on the bottom, since n is more than m, this this term matters. So we'll have x to the power of n. So on the bottom. So basically this is going to be 1. So when x goes to infinity, since n is more than m, this grows faster than this, and this becomes 0. Like for instance, if x is m is like 6, so x to 6 over x to and n can be higher, like 7. This is 1 over x. So when x goes to minus infinity, this goes to 0. That's just an example. So what we are left is when we have m less than 4 and n equal to 4. Then let's see what happens to our limit. So on the numerator, m is less than 4. So what matters is that this term grows more than this, because this is x to the 4 and this x to the m, which is less than 4. So on the numerator, we'll have 3 times x to the power of 4. And on the denominator, since n is 4 and x to the m is less than 4, we have only x to the power of n, which is x to the power of 4. That matters. So this is going to be, this 2 will cancel out, this is going to be 3. So these are the only 3, 0, 2, 4 over 3, 1 over 3, and 1 over 2 are all the distinct finite solutions.